Welcome everyone. Thank you for joining me today. In today's presentation, I will use the journey of a cloud application in order to provide you some useful information on how to ensure that applications that exist inside of containers are resilient to changes or can scale while using Kubernetes. Also, I would like to point out some things related to my experience as a developer with Kubernetes and Helm, and how Helm has helped me to deal with things that are not so Java developer friendly or developer friendly in general. But first of all, a little bit about myself. I'm Ana. I'm the only female speaker from this conference, as told in the keynote this morning. I'm an application developer by profession, and I am a yoga practitioner in my spare time. This is where I get some of that control enthusiasm. Yet some other part of my control enthusiasm comes from what I do in my daily job, where I try to understand how things are working end-to-end while coding, and to understand how I can control both my code and also what's not under my control. And this is why I have become interested in containers and how to use Kubernetes as a developer, and also how can I manage the Kubernetes while developing my code and make this experience not so tight to Kubernetes directives directly. First, the agenda of today. So today, why Helm and Kubernetes? Some application setup, because we need an application to deploy with Kubernetes. Kubernetes and Helm deployment of that application, obviously. And some retrospective and some key takeaways for today. So first, why Helm and Kubernetes in the cloud application context? Well, Kubernetes helps us manage containerized applications in a cluster environment. That's the definition. We kind of all know it. So, but its goal is to provide better ways of managing related distributed components across varied infrastructure. So what happens is that in the context of your application, the one you're coding daily, you're doing constantly changes to that. And you want to be able to sustain, grow, to have flexibility in terms of application evolution, business needs, business is growing, or disaster recovery, or automatic updates, and so on. So in order to have more good things with your application, you just go ahead and add some cloud to it. Well, you have now a cloud application, and you're doing nice code. However, you would also like to have a pattern of doing the deployment, and this is where you're doing DevOps. So the idea of doing DevOps is a way of patternizing the way you're doing the deployment. Sorry, I'm a bit nervous. It's a way of applying patterns in the way you're doing the deployment. And the reason why you're doing this is because you would like to be able to have multiple deployments per day, or to have rapid feedback on what you have done and how would that work while interacting with other environments. Yet, this might look enough. However, if you would like some portability, then you add containers and Docker. If your application is having like multiple microservices, so you're using microservices and you have a lot of those, and with each of those you're using a Docker container, it can become a hell at some point in time to orchestrate all those. And you need some kind of an algorithm in order to have a good orchestration of that. However, Kubernetes comes to help us and offers some out-of-the-box features like auto-healing and sometimes auto-scaling and other nice features. And it helps us in achieving smooth deployment while not preoccupying ourselves with how exactly are we going to do that to the letter with the Docker containers. And after applying Docker and Kubernetes and so on, there's one little pain that we have as developers. Deployment with Kubernetes means making manifest files with Kubernetes directives, or Kubernetes primitive or generic primitives. And while you're doing this, for each release, you should modify that file, that deployment file, or multiple deployment files. And this is pretty difficult to do as a developer and pay attention to that all the time. And this is why Helm was invented, so that can help us, both us, the developers, and the operation people, to be able to manage all those deployments in a much smoother way and to not be preoccupied on applying values to each of those deployments all the time. And in today's presentation, I am going to take you through application, Dockerizing it, Kubernetes, and then Helm. Hope we have time for everything. So in every journey, we need some prerequisites before going ahead and doing that journey. So as developers, we need an IDE, a platform as a service account with Kubernetes cluster support. And you have an example in the parentheses, but you can choose any cloud provider that offers you Kubernetes cluster support. Or you can run it on localhost, but it might take some resources. Source code repository account configured. Use your GitHub or any other source code repository to keep your code there. An account in a container registry, and you can use either a private container registry, as I have in the presentation today, or either your Docker Hub account. Optional a Docker environment running on your local host. And Kubernetes command lines and Helm and Tyler installed. So the Kubernetes and Helm command lines installed. Because I'm using Windows, this is my setup for today. So I have the bx.exe, which is the IBM Cloud command line, together with Helm and kubectl installed on my computer. And the way I'm doing things today is because I want to run from a single command line all the things I need to manage with Kubernetes in my cloud and all Helm and everything else. So all these three sitting next to each other, it makes it smoother for me as a developer to interact with Kubernetes directly in the cloud. So let's go through the application setup. Now, this is not a very difficult application. So from application perspective, it's a simple Spring Boot application that's managing the book acquisition. I didn't want to just go into too much detail with the application. And I think Mark in the morning has showed you how to make a Spring Boot application very, very easily. So it just book acquisitions with 3 Rust controllers, very easy. And typically for this kind of application, this small application, you would require some kind of a deployment descriptor to run it in the cloud, so to deploy it in the cloud. And a typical deployment descriptor would be as follows. For the Cloud Foundry-based clouds, Cloud Foundry itself or IBM Cloud, which is Cloud Foundry-based. And using this manifest, I can smoothly deploy my application in the cloud. So you can see here I'm using a database service. I'm just applying where's the host name for my application, the path to the ward, how many instances I want to run, what's the build pack that I'm using, and so on. However, we talked about portability. So if we want to port this to, let's say, another provider that doesn't know very well how to interpret this one, how do you do it? Well, first thing, you would get rid of the one that is not being seen by the other provider. And you can get to a development scenario where you just get the Java application and you need something else to help you into deploying it. And this is where containers come in action and can help you. So for today's development scenario, we're going to have the book acquisition application, as described earlier, available in a Docker container, and the image of that Docker container is going to be in a private image registry, using a database that's not inside the Kubernetes cluster. It's outside of the Kubernetes cluster. It's in the cloud. So it's a Cloud on DB managed service by the cloud directly. And I want to be able to talk with this service that's outside of my cluster in a very smooth way and to be able to question it and to store data there and do all kinds of operations there. And then I want my applications to be here in the Kubernetes cluster, and I also have smooth orchestration of my deployment using Helm. So let's dig in. First thing that we need to do for a containerized Java application, you need a Docker file. So my example of Docker file is as follows. And I would like to point out that it's very important to have an official released Java image as base when you're doing a Docker file for a Java application. There are multiple official repositories where you can get an official released Java image. In my case, I use the IBM Java. And it's very important for you to have it because you have to be able to accept the licenses without having any doubts on what you're accepting there and that you're using a genuine product. I just added my code in a repo. I did everything in my folder code and ran mvn clean package using a small hack. So when you're creating a Spring Boot application from start.spring.io, you get an archive with the application. And together with that archive, you get some scripts called Maven wrapper. So those scripts called Maven wrapper can help you when you're doing the Docker image, and you can run those scripts with the following command here, with mvn w clean package -pur. So this is like I would run mvn clean package from my local environment. However, I'm transferring this to the Docker file and saying, okay, use those scripts because they are there, they're provided when I'm creating my Spring Boot application. So why not use those and build my war? Then I'm just simply renaming my code into app war and stating genuine entry point to the to how to start my application when the Docker file will be ran. So that's pretty much it. The commands are standard, and the last part is inspired by the guides of Spring Boot and for Docker, and the first part is partially mine because I've used some scripts already provided. But it's a way of doing things. However, if you plan on doing differently, there are some other options. You can build your application locally with the all-known mvn clean package with your profile you want it, and do mvn clean install or whatever you would like else. Then you can include the result inside the image, and that's it. And then you're going to push your image by yourself. So you are going to do a management by yourself of what's happening there. Now this is good when you're starting your project and you want to just get acquainted with the technology and see how things are going for you, if you understood how Docker is working for you. However, on the long term, you have to think how would a pipeline, a DevOps pipeline, would transpose these in order not to be binded to what you're doing locally. So option 0 still the better one. But still, option 1 is good for a ramp up. Option 2, manage your Docker image with Maven. There is an official Maven repo that gives you both Maven and an official release Java image. So you can take any of the official release Java images. And you can again run mvn clean package -pur and create your Java application. And again, the commands are pretty straightforward and easy. As you would do it in the local environment, from the command line, you would say java -jar app.war. So you would start it from the command line. This is how the Docker image would be created for you when this is being built and later pushed. So these are just options. You can choose whatever you would like for your approach. Personally, I would choose between option 0 and option 2. And said option 1 would be just for a rapid ramp up. And then make it available in the cloud. So for Docker image availability, as mentioned before, the first thing you do, you'd have to build it and then push it. So you build your image, and then you push it to the image registry. And you can do this as many times as you want. So, however, as a developer, you might get tired on doing this constantly because maybe you're doing some mistakes in your code, in your Java code, or you're doing some mistakes in the Docker image. God knows. It can get tiring to just go and say build, push all the time. And also you like to interact with the cloud. So by interacting with the cloud, I just use bxcr build -t. And this command just does for me build and push in the same time from the command line. So I am building my Docker image, but I'm also pushing it to my private image registry because I don't want to do these two all the time. I just use this one. I use what the cloud gave me. So I'm helped by the cloud. And then I can inspect if everything's okay with my image and it's there, just to check. It's always good to check your things. Then you think, okay, I want to automate my work. So to automate your work, you would create a script with either row 1 or row 2, and you would source it in your pipeline. So this means that you're not going to execute manually all the time you need to do a deployment. You're just going to source what you created before with those 2 commands from upstairs, or just 2 from here. And this is how you could automate your work, and you could put the pipeline to work on each commit that you're doing and each push that you're doing. You are just continuously running your updates. So there's no need for you to run manually those things and to update those manually. so this is a quite neat thing, and it gets rid of a lot of pains from developers' perspective, how much work will be needed in order to maintain an up-to-date Docker image. Then next thing, after making an application, making a Docker image available, would be Kubernetes and Helm deployment. Just a quick history for Kubernetes and some Kubernetes concepts. So, right, typically in a Kubernetes cluster, like I have here, example, right, you have two types of nodes. You have the master node and worker nodes. And when you create a Kubernetes cluster, you are deciding, okay, how many worker nodes do I want to have in my cluster? And this is when you're saying, yeah, I want a 3, 5, 10, 1. The master node is very important because it places container workloads into the pods of the worker nodes. So the master is controlling the workers, as everyone knows. And how is this thing happening is because we have the API server, which is the management hub for Kubernetes master node, but not only. So the API server is the mastermind behind managing the entire cluster. And this API server is using the etcd, which is a data config for Kubernetes. And there you can store all the configurations related to your cluster. It's like dot properties from Java, but transposed to Kubernetes. And then the controller manager is the one that is ensuring that the cluster desired state matches the current state of the cluster by scaling workloads up and down. So this means that the controller manager is continuously checking that your state that you're having now is the one that you intended when you did the deployment. And when you are going to describe how your pods are doing and describe how your services are doing, then you're going to get some information in response of like current status and desired state. So you're going to see both what is now and also desired state. And desirable is to have the same values in both. So current state to be matching the desired state. And this control manager is saying how is the state going to the API server and communicates directly with the API server. Also, the scheduler is the one that is assigning workloads to specific nodes in the cluster. So these two, as you can see here, are directly talking with the API server. Then the API server acts as a translator to the worker nodes or to the kubelet that's here in the master node and translates those commands to the kubelets. The kubelets are the ones that are receiving pod specifications from API server and manage pods running in the same host. So one thing I wanted to mention to you is these two pods share the same host. So every time that this kubelet receives informations or pod specifications from the API server to do something, it will manage these two only. So do not think that there is a mixture of kubelets randomly in the Kubernetes. And since we're talking about pods, pods are top-level API objects that are running containers. They're the smallest compute units in Kubernetes. And pods are actually containing your containers, your Docker containers. And these pods are helping you to have a group of collocated containers inside them. You can associate volumes. They have a unique network IP, and they have a lot of options on how to govern the containers from inside them. Then these pods can be filled with containers by using deployments. Deployments are those that are used to schedule pods with actions. So you can do, using deployments, you can have replication management. And this means in terms of Kubernetes to have like ensure that the right number of nodes and containers are available for the requested workload. Then to have pod scaling or rolling updates, roll back to previous version. So you can, if the current state of a deployment is not stable, you can always roll back and go back to a previous state when you were stable. Or you can scale the deployment to facilitate more load. You can also clean up old replicas that are not needed anymore. So if you have replicas that you don't need anymore in your environment, you can just clean those by using certain policies. Or you can pause or resume your deployment to apply multiple fixes in your pod and then resume it to start a new rollout. So it's like, okay, I just realized I've done something wrong on this deployment. I'm not going to go through everything. I'm just going to stop it and then go back to the state that where I was when I stopped it. And another thing that's very important for us, for developers, are the services. So the services offer us a stable virtual point to access what is in the pods. So we have containers in the pods, and we need a way to access those containers. And services are a way of knowing what we have there, so the way to access our deployed applications. And in order to get the services, we can use selectors. And I'm going to show it to you when I'm going to do the deployment.yml. Before going into deployment, we need some Kubernetes pre-deploy stuff. So we need to create a cluster, verify it, and access it. And I'm going to show you some command line, some commands for the command line, but you can do it also visually from the catalog from Web UI. So a typical command to create your own cluster in IBM Cloud would be bxcs cluster create, followed by a lot of options. But the most important ones are the name, the cluster name, and the number of workers. So how many workers will you assign to that cluster? And then you would verify the cluster by using bx clusters or bxcs workers. So you just query if things are okay with what I just created. And this is a way to ensure that you have done the right thing if you're working with the command line. And then you can access it by using bxcs cluster config, either this or either kubectl config use context for the cluster that you have just created. So you need to position yourself inside the cluster from the command line in order to be able to control it with Kubernetes commands. So this is and to interact more with it directly from the command line from your local host. And also these kind of commands are useful to be done in scripts for the cloud delivery pipeline. And then you just set, in my case, because I have Windows, or export the kube configuration. So I'm just placing myself, okay, I want to use this cluster having this configuration. And then I can just go and see how my cluster is doing through a dashboard using kubectl proxy. This is pretty much it with doing the with creating the cluster. In my scenario, I was stating about an application that is being somehow able to get data from a database that's in the cloud, so it's not in the cluster. And in order to be able to communicate with that database that is outside of the cluster, what I am doing is that I'm doing bxcs cluster service bind, so I'm just binding my cluster to that service. Why I'm doing this? Because I want to be able for those to see each other and to know that they belong to each other, or actually that the service belongs to the cluster. And the kube namespace is very important because in a big cluster where you have multiple worker nodes, there would be the case where sometimes certain worker nodes shouldn't be able to see an external service. So they shouldn't get access to that service. In order to ensure that you do not get access to that service, you just put the namespace. So the namespace is helping you to separate the things that you have inside the cluster and to ensure that you're not accessing things that you shouldn't see from those worker nodes. So at the end of running this command, I get a secret. As a result of that. So Kubernetes secrets are used for handshake between what's inside the cluster and what is outside the cluster in that case. So this is a kind of secret that it's going to help me to handshake with the database and say from the application, yeah, I want to use that application based on the information I have in this secret. I am allowed to use this application because I know the contents of this secret. And for the actual Kubernetes deployment, I need to change a few things in the application code. So one thing is to set the path to the mounted secret. So you would need to specify where is the path to the mounted secret. And how do you know where is the path to the mounted secret? Well, I will show you shortly the deployment.yml, how it's done. And I will show you where I'm mounting my secret, so you could see where the path exactly is. But inside my Spring Boot application, I just really wanted to make sure that I'm seeing the secret. Then I simply inject or config it. Depends on how you're using the configuration in Spring Boot. I just simply inject it with that value. And I specified that path there. Then for reading the secret, it's easy. You're just doing a file reading from somewhere that we are specified the path. So this is pretty much it for reading the secret. However, if the secret is encrypted, you would need a few more things to be added from the Java side. Yet it's nothing extraordinary or difficult to be done from a developer's perspective in order to get handshake with the service outside the cluster. Then the deployment YML. It needs two parts, the application description and the service description. And since we got here to the deployment YML, let's see how it looks like. Okay. Hope I can see this. Delete it, because I don't like it. Okay, so it has two parts. One of those is the description of the application. So this part here is what application I'm going to deploy. In my case, it's called BookBMX Demo. And I'm going to use just one replica for this application. I don't need more. And the kind of deployment that I'm doing, it's deployment. So you got the kind of specified to the deployment of the application can be either deployment or can be stateful. If you have a stateful application, so deployment is equal stateless application. So I'm going to deploy a stateless application in this case. And then the name of the application is pretty standard, BookBMX Demo. And then I have a service part, because after I will deploy this application, I want to be sure that I can go ahead and access it somehow. And I need to define a service on which I would know that if I'm accessing that service in my cluster from another application that's in the same worker, I would be able to go to that and see how it behaves. So in my case, I just added the same name as for my application. So I said, okay, I want service BookBMX Demo to be given to expose to the rest of the neighbors from the cluster. So these two here, and then I need to specify what are the contents of my deployment. So I need to specify the containers for that. And then to specify the containers, I would need to specify a name for that. I said it the same as my application. An image. So I'm saying directly, where is my image located? So in the private image registry, in my registry namespace, and I have the image name with BookBMX Demo and the tag 37. It can be any number here. And the image pool policy is always. So this means that all the time that I'm going to do a deployment, I want for the image from the registry to be retrieved from that area. However, the application deployed there, as mentioned earlier, is using a secret specified somewhere with a path. So in order to be able to use the path, you have to mount some volumes. And to mount some volumes, one sec. Yeah, you would use this. Volume mounts, and you can use this, it belongs to the container, and you're saying the mount path, and you can say here whatever you like. So it can be GG, if you like, or whatever. The idea is that the mount path is going to be used by your application. So you can set there whatever you like, but be sure that your application is going to read it from there. So this is like you are creating your folder, your virtual folder, where you are going to read. This is used only by your application, because the secret is there in the cluster. There is no need to preoccupy yourself of thinking, maybe, oh, where did in the cluster it was put there? I wonder what folder, or whatever. No, this is something that you manage. So for the sake of it, I'm just going to go back to what I said here. And then I set service name, service bind volume. Then I have to specify these volumes here. And for volumes, no, I don't like it. Come on. Sorry for that. It's difficult to see after this panel. Okay, come on. Just okay, some bound volume. Yeah, that's what I was looking for. So, okay, come on, make yourself green. Ah, perfect. So, the volume mounts and the volumes have the same name as specified in the volume as service bind volume. Again, this is something you can also define as you please, so you can be GG again, if you like it. But all the time make sure that's going to be GG here too. So they would know about each other. So this one, volume mounts, is referencing what is actually containing in the volumes. So please be aware to have the same name. Like, otherwise you won't be able to see the volume itself. And then you're just reading the secret name. In my case, I know that the secret name is this one. Because when I have created the BXCS service bind to the cluster, then I have obtained as a result this name here, binding book minus DB minus Cloud. And this is how I just managed to know which secret is, what's the name of my secret, and later use it in my application. And then this is pretty much it though. So this is a pretty valid deployment.yml. It's important to be green all the time. I always have this issue here with X, but it works, trust me, and I can show you the application up and running. However, the hard part of doing these things is because you always have to make sure that you are indenting correctly, and for a developer that comes from the object-oriented world, it might be a little bit difficult. And since I don't like to do this often and repeatedly, again, I have created a script for that. So in order to deploy that manifest, I don't want to do all the time Kubernetes commands from the command line. So what I did was to make my own script of kubedeploy.ch. And I simply apply repeatedly my configuration from deploy.yml using the kubectl apply command. So apply, what it does, it takes the configuration specified in deployment.yml and is applying it repeatedly to what I already had, if I already had something, or is installing using that configuration. Then I'm checking how my deploy service is doing, because you always have to check if things are working for you. So one way to check how your deployed service is doing is to describe the services called bookbmx demo. Hopefully it's going to be only one bookbmx demo. And this is how you get what happened with the service that you deploy. So you are going to get some details on how things are working after your deployment, and if you can access that service that you described in deployment.yml, then you can see how your pods are doing and how is the application inside your pod doing by simply issuing kubectl describe pods -- selector. So you can use the label given to the application bookbmx demo in the deployment.yml in order to be able to get how your deployed pods containing that application are doing. So this is how you can see if they're healthy or not, if they're struggling to scale or not. And this is a good way to ensure that everything worked as intended when you did the deploy. So this way of doing things with kubectl apply -f deployment.yml is called the declarative app management of doing things with Kubernetes. There is another way of doing things, the imperative way of managing your application with other primitives, with other commands actually. It takes more commands from your side as a developer. For me personally, it was easier to use just the kubectl apply -f deployment.yml. And simply all the time, I'm just updating the contents of my pod with what I already developed in my application, and this is pretty much it. So I am done. Everything's okay. The deployment works. The application, one moment. It's around here. Wait a minute. Yeah, it's kind of working. So it would be pretty much done. However, on the long term, this is not okay. for a developer because you need some kind of flexibility in order to maintain the deployment.yml. You don't want to go all the time and update the values of the tag, of the registry that you're using, of the image name, and all these things. And this is where Helm comes to your rescue. So Helm charts represent packages of pre-configured Kubernetes resources. You could say there are a bundle of Kubernetes resources in order existing there to help you to describe better what you're trying to do in terms of deployment with Kubernetes. So Helm charts represent typically a hierarchy of files containing a package description, the chart.yml file here, and templates for doing the deployment. So this is what we refer in general to Helm charts. And these templates are very useful because they can receive multiple values. And you can change the values much more easier just using templates. You're applying patterns, again, to the way you are doing the deployment this time. And this is the developer perspective. However, from the operational perspective, Helm means to have two parts. It means to have a client, Helm client. So every time from your command line, when you're issuing a Helm command, like Helm init, Helm create, or any other command, you are being the client. And it has a server called Tyler. And the server typically is where is in your cluster. You can have a cluster, you can try to do it on localhost also. And you have the Tyler on localhost. However, it's not very productive. Yet, in the cloud, what you would have a client installed also, and the Tyler installed. So the client is going to issue commands, Helm commands, able to be interpreted by the Tyler, and later on be able to work with deployment.yml manifests of Kubernetes much easier and do the actual deployment. So these two components are actually helping you in terms of deployment and to speed up your things from the development part of looking at the things, and also to help you have a more organized structure of your project. So let's see some Helm concepts that I'm going to use further in the presentation. So I'm going to use the term of release. So in terms of a release for your Helm, it means a chart instance loaded into Kubernetes. Each time that you're doing a Kubernetes deployment, or actually each time that you're installing or upgrading the charts, you are doing a release. Repository means a repository of published charts, and there are various published charts by vendors describing their products. So vendors that make the databases, or for example, Open Liberty, a server is being available on, it has published charts in order to be able to use that in your Helm charts later on and to be able to build that more easier. So you would not require to do that from zero. Then the templates, as explained earlier, there are Kubernetes configuration file, values. So values is going to be the place, the file where you're going to store those hard-coded things that you saw earlier in deployment.yml. And it's more simpler to maintain, only one file for for all the templates. And optionally, you can use requirements. So requirements, I'm going to show an example later, is an optional YML file where you can list dependencies for the chart. So for example, if you'd have an application that requires a server that's also described by Helm chart, you can list the dependency to those charts in the requirements.yml file. Then, for the Helm charts creation, it's easy. You can just do Helm create and the name whatever you want. And you would just get this hierarchy here with all given, containing values.yml, your values, your package description, as mentioned earlier. And now what you saw earlier in deployment.yml gets splitted in two parts. So the deployment itself concerning the application, where you specify the containers and the volumes and so on, is going to get here in deployment.yml. The service through which you can access that deployment.yml is going to be in the service.yml file. So you're splitting the concerns. And the ingress.yml, because we haven't talked about ingress so far, well, the ingress.yml file is a file to configure the roots of your application, because you're not going to, in a typical application, you're not going to access an IP with a port. You're going to access a root, host name. You're going to have something more beautiful there, not just a simple IP with a port and get into that application. So this is pretty much it for the templates, and also charts folder if you want to reference other charts in your project or just to put additional charts in your project. And then you can check those charts by using the Helm lint command. So this is a pretty simple command. It's not doing a lot of checkups. Sometimes you can get some errors when you're using it. So it's not always validating 100% what you have wrote in your Helm charts in terms of templates. Because as you will see in a moment, I will alter my Helm charts to fit my deployment. And this is pretty much it. Let's go to the command line for a moment. Okay. Hope everyone can see. Yeah. So Helm create, book, manage acquisition. I'm not seeing very well. Wow. Come on. Good. Then going back to here, I should be able to see a new folder. Okay. Yeah, the book acquisition folder. So here I have values. This is auto-generated when you're executing Helm create. And you got all the templates here and everything that you need. Also description of the chart. It's being pretty easy. And you can put here also maintainer who maintains the charts and so on if you want to be able to track who did that chart. Then for the values part, I'm not using this. Then I'm just going to go and delete these things. Values. Yeah. So these are corresponding values to my deployment. So again, I'm just stating here about my red image. So my image is being obtained from this from the following repository. From the following repository, what tag I need to use, what pull policy I'll use. So as in deployment.yml, I'm going to use always. If I need any secret to be pulled, the secret name for my database, and again some description for my service. So what's the name of my service, what type of service I need, an external or internal port. And then this is pretty much it from the values perspective. However, later on when I'm going to go and interact with these, for example, in service.yml, here I'm not changing anything because I already have everything up to date. So it's already done for me. Why go and changing? It's just taking the values from what is already pre-configured in the values.yml. So going with this forward is pretty okay for me. Now, the deployment.yml file, this is good also. However, if I look to the specifications for the containers, well, I did not see the volume mount. So here is where I have to add a few things. So first of all, I need to add something regarding the, to the volumes. And I'm using, again, values specified in the values.yml file. So I'm just putting a template here of, just go in values.yml and read the property secret name that you can see under image. So it's pretty nested the way you can read into the values.yml file. And then I'm going to use this volume from here and going under the image pull policy and see. Come on. Okay. Helm volume mount here. And this is pretty much it. I haven't had time to change these mount paths and the name here because I could have provided this also in the values.yml and not hard-coded here. So this is a bad thing for me. And this is enough to describe my application deployment later on. The helpers.tpl are actually the templates that I would need later on to replace things in the charts. And the ingress, as I mentioned earlier, is the way of defining the routes on how to access your application. So this would be just enough to describe the BookBMX demo application. However, I also mentioned to you about the requirements file. So you can think of the book BMX demo application as an application that's being, it exists just as a backend. However, if the front end would be in another place, in order to do that, I would need the requirements.yml. So, one moment. Come on. No, cancel. New file. Okay. And the requirements.yml for me, would be like this. First of all, I want the backend to be first. And I'm going to go here. Come on. And referencing for here. So I'm saying that, okay, for the backend of this application that I'm trying to deploy with Helm, what I'm doing is I'm taking a description of this from charts, and I can just go and copy paste the contents of charts that had the values previously used. So what I'm doing here, I'm just using charts with different values, and also with values.local if I want to use certain values only for local. And then I have the front end at another GitHub repository, and say that is also described by Helm charts. And I can put these two together when I'm doing the actual release, and they're binded together only by these requirements.yml. And in the templates, I would not require anymore this deployment and service, because now I'm just splitting the concerns to the requirements.yml, and I'm taking those based on requirements.yml. Yep. And this would pretty much be it. And of course, of the values here, I don't need those values here, because what I'm going to do is I'm going to say, okay, make me 2 deployments, one with the front end and one with the back end, and then one with the front end, and bring them together. So these values here, I don't need it anymore to exist. Only if I would need something globally declared, I'll use it here. And this is pretty much it on how you would do to bind things together and use the requirements.yml to gather your things. Or also, as I listed here, you can use a repository of already published charts as dependency and add those to how you're building things. And you would require this one first if you need the Liberty server first, and then put the back end and then the front end. And this is it with the Helm for a more elaborate scenario of doing things. Let's go back a little bit. Okay, we know how to make charts. Now we have to deploy them. So first of all, you need to configure the tiler. For configuring the tiler, the commands would be first to Helm init. So Helm init, without minus upgrade, would actually install both the client and the tiler for you. So it will put the client and the tiler in the cloud. However, minus upgrade, I'm just upgrading if tiler is already present. I just want to make sure that things are there. And then I'm going to check, how is my tiler doing? My tiler is a new pod. And what I'm going to see, I'm going to check the status of that pod by using kubectl rollout status, and check, wow, how's this tiler doing in the namespace Qt system? And I should say it is up and running and is okay. Then I just make some additional checks on Helm version, or Helm listing or Helm listing previous releases in my namespace in the cluster, and this is pretty much it. So this would mean configuring the tiler. Then also deploying it would mean issue just a part of this command, Helm upgrade -- install a release name, whatever you want, and you just say here book BMX demo. This is a chart name. Or book acquisition in our case, what we just recently created. However, because I have this script sourced in the pipeline, I'm just putting these as variables, and I'm replacing them at the runtime. So, and also I have added here --set in order to show you that if you have values already specified in your deployment, however, you've changed your mind about certain values from your file, and I don't know, maybe it's too late on what you have done, you can just go ahead and do again some setups on your values. So you can just go and say --set the image repository, the tag, or whatever else you have in the values.yml and overwrite the contents of your values.yml while you're issuing the Helm upgrade command. So this is a way of escaping from deploying something that's, I don't know, maybe stalled. Maybe the values.yml contains values that are not already up to date, and you just want to override those in an instance without going and modifying the values.yml. So this would help you in some difficult moments. So this is about deploying. And all the time I'm saying Helm upgrade because I want to be able to upgrade my application. I'm doing changes to the same application. I'm not doing a new installation of my application. So this is why I'm using Helm upgrade. And then check my deployment with Helm status, and I'm just checking the release name. And then I'm just checking the cluster availability and getting the address and how the application is doing at the specified IP address and port. So this is the basic. Then you can just go furthermore and inspect at which hostname I can find the application and how I can get access to it based on what I have defined in the ingress.yml. Some retrospective and some key takeaways. So the journey retrospective consists of well, you have a code repository, you check that you have Docker installed, and then you build your Docker image. And then you are storing it in a Docker image registry. I have also some build.properties stored in my environment, in an archive there. And then I validated my image in the pipeline using a vulnerability advisor service. This is particularized to my scenario and to the cloud, so this is why I haven't described it so far. This is just a way to ensure that I am securely having that image there. And so I'm checking against some security patterns that the image is okay. And then I'm doing the Helm deploy with the pre-deploy job where I'm just configuring the tiler. And then I am deploying the job. I'm deploying everything using the Helm upgrade -- install command. So this is pretty much it. And some key takeaways that I want to share with you is that, from my perspective as a developer, it helps a lot to have Kubernetes deployment to be so agnostic of the programming language that you're using. So my front end, maybe, I don't know, maybe it's a Node.js application, so I have the front end running separately on a Node.js application. Yet it doesn't care, the deployment.yml does not care on the underlying language that I'm developing the application. So this is a helper for me as a developer. However, navigating to generic primitives in order to make a deployment was a little bit difficult in the beginning. Then there's a good process isolation in terms of what you're doing in a deployment. So you have everything in pods, everything very structured. Now Helm is helping us developers to maintain more easily the Kubernetes deployments by using templates to those deployments. And you can extend the multi-environment capabilities of Kubernetes by using multiple values.yml charts. So if you want, you can apply, instead of Helm upgrade -install, you can say -f, and you apply a different values.local.yml if you are working on local. And you would use those just for yourself on local. And any other type of values.yml can be applied based on the environment that you are trying to deploy. As a personal recommendation is not to track secrets in your revision control. So one thing is that in order to be able to replicate how your application would interact with the secret, you would have to somehow mock that secret for you to be able to test with it. So if you're making like a file with a secret that would simulate the secret, do not put that into the revision control. Then plan a good distribution of services across clusters. So plan very well what you're going to put in which pod and which worker based on who should see what from your artifacts. Create a dedicated chart per code artifact produced. So this is especially for those of you that are making microservices. So make a chart, as I did with Helm Create, per each artifact of Java or other language that you produce. And you can, as again, manage environments with multiple values.yml files. And this is pretty much what I wanted to share with you today. I want to thank you for listening to me, and if you have any questions, not sure if you have time right now, but you can find me here today and tomorrow, and we can debate more. Thank you very much for listening to me.